Hello everyone, welcome to our lesson 5-4 notes. And today what we're going to be discussing is how to divide with powers. So far we have talked about what happens when you have something raised to the power of 0, what happens when you have something raised to a negative power. We talked about when you multiply terms that have powers, that you're actually adding those powers. When you have a term raised to a power, you have to multiply those. And today we are going to discuss that when you divide terms with powers, you're actually subtracting the exponents. You're subtracting those powers, okay? So whenever you have something like this, a to the power of m over a to the power of n, you're just subtracting those two exponents, a to the power of m minus n. Applying that to two terms, x to the power of 7 over x to the power of 2 is the same as x to the power of 7 minus 2, which equals x to the 5th power. And I wanted to show you what is actually taking place here. So I wrote my x to the power of 7, which is the same as x times x times x times x times x 7 times, and then x to the power of 2. Okay, and you know that anytime you have a fraction, say 3 over 3, that those 3's will cancel out and you end up with a 1, right? So when we're dividing with powers, that's very similar to what we're doing. We could get rid of 1 here and here, 1 here and here, and then we are left with just 1, 2, 3, 4, 5, x to the power of 5 over 1, which is the same as x to the power of 5. So this is what's taking place when you are simplifying expressions in division with exponents. Okay, so this next one you can try on your own. Actually, probably this entire page you can pretty much figure out on your own. I'm going to go through all the notes. We have c to the power of 4 minus 7, which equals c to the power of negative 3. But remember, we do not want negatives, so we have to rewrite this as 1 over c to the power of 3. All right. Example 1. I'm just going to work these out. If you want to pause the video and come back, you can. Notice these are the same, examples 1 and 3, except the numerator and denominators are flipped, just to show you that when you end up with a negative, you will need to rewrite it so that your exponent is positive. Same thing with examples 2 and 4. See, the bad thing about messing up on this is that sometimes I probably won't even notice it. Okay, those are pretty simple. Okay. All right, so we're just now, instead of our terms being variables, our terms will now be numbers. And you will have to simplify these all the way out. And what that means is that you will have to end up figuring out what the answer is. So for example, we have 3 to the power of 5 minus 3. Since these two terms are the same, we can leave them there. We can leave it as 3. And so we end up with 3 to the power of 2, which is 3 times 3, and that is 9. Okay, our terms are the same here. Our base numbers are the same, 5. So it's 5 to the power of 4 minus 3, which gives us 5 to the power of 1, which is just 5. Okay. 3 to the power of 3 minus 5. Same situation here. We're just flipping our numerators and denominators. We get 3 to the power of negative 2. We have to rewrite that as 1 over 3 to the power of 2. which is 1 over 9. And so you could probably, oh, the numbers are a little bit different here. Okay, let's see this. 5 to the power of 3 minus 7. 5 to the power of negative 4. 1 over 5 to the power of 4. And 5 times 5 times 5 times 5. So we have, these are 25. These are 25. And it'd be a really good idea for you to try to memorize 1 through 25 when you're doing squares. And so it would be 1 over 625. It just makes it go a lot quicker if you know those already. All right, that's page 1. Move on to page 2. So far, so good. Now we have variables with negative exponents. So we're gonna do some of these. And I know there's a lot of practice, but I wanna make sure that you're ready to do your homework on your own. Okay, so we have a to the power of negative 4 minus a negative 9. Now I've been saying this all year long. Minus a negative is the same as adding a positive. It's this, you're adding the opposite. So really this would be plus 9. So you have a to the power of 5. Okay. B to the power of negative 5 minus a negative 3 is adding 3. So now you have b to the power of negative 2. Can't have that, right? It's like in Slope Dude when they say the word undefined. We need a video with these. You can't have a negative exponent. Okay. D to the power of 5/4 minus 3/4. And again, the only reason we can do this is because our terms, the D and the D, they're the same. If they were different, we couldn't do this. Okay, so we have D, 5 minus 3 is 2. Our denominator is 4. And fractional exponents can be simplified. So this will simplify to d to the power of 1/2. Okay. Y to the power of 7/8 minus 1/8. Y to the power of 6/8, which can simplify to y to the power of 3/4. Okay. Now, instead of variables, we have coefficients. Now, before I do these, I want to look at your notes here. Whenever we're solving problems involving exponents and division, the first step is to rewrite your problem by moving all terms to the numerator. And that's what we did down here. That's what we've been doing with all of them. If you're writing out all the steps like I am, that is our very first step. I moved x squared to the top when I wrote it out like this. Then you subtract your exponents, which I did. 7 minus 2 is 5. Then you rewrite your problem by getting rid of any negative exponents. In this case, we didn't have a negative exponent, but in this case, we did. So then I got rid of it. That was step 3. Step 4 says to simplify your coefficients if you have them. Now, up to this point, we haven't had coefficients where we needed to simplify, but starting with example 13, we do. A lot of you have been getting confused about where the exponent goes. So if you look at example 13, you can pretty much separate these two right here, and you have two different division problems. You have 14 divided by 2 and c to the power of 4/7 divided by c to the power of 3/7. Okay, so I am going to do this. 14 divided by 2, and then I have c to the power of 4/7 minus 3/7. Okay, Probably needed to make my C a little bit bigger. So I know that 14 divided by 2 is 7. And 4 minus 3 is 1, so I have C to the power of 1/7. And that's your final answer. Okay, let's go over to one that does not result in a whole number. So I have 24 divided by 36. And I have y to the 10th power minus the 5th power. Okay. Now, 24 over 36 does not divide evenly into a whole number, but they do both have a common factor of 12. That's the greatest common factor. So if I divide both of them by 12, I will end up with 2/3. Okay. And then y to the power of 5. Okay. Now, a lot of times the way that you will see this written, and this is probably the most common way, is 2y to the power of 5 over 3. Because if you think about it, this y over 5, it can be turned into a fraction with a 1 under it. So this would be the most accurate way to write it. All right. Example 15. We have 10 divided by 5. And then we have x to the power of 12 minus a negative 9 is going to be plus 9. Okay. So we have 10 divided by 5 is 2. And then 12 plus 9 is 21. So 2x to the power of 21. Okay, let's try this next one. 12 over 18, 12 divided by 18. And then we have b to the power of negative 8 minus a negative 5 is plus 5. Okay. So the greatest common factor between 12 and 18 is 6. So if I divide those both by 6, I get 2/3. And then b to the power of negative 8 plus 5 gives me a b to the power of negative 3. So we're going to have to do something with this problem because we can't have a negative. Now, I want you to understand, though, that that negative 3 is only attached to the b. It is not attached to the 2/3. Okay, if it were attached to the 2/3, it would look like this. 2/3 to the power of negative 3, b to the power of negative 3. Or it would be written 2/3 b in parentheses raised to the power of negative 3. So that would be how that answer would be written if the negative 3 was applied to both. But in this case, it is not. So we don't have to move the entire answer down. We're just going to bring the b term down so that we can get rid of that negative exponent. So you end up with 2 over 3b to the 3rd power. Okay. All right. If you have any questions about that problem, please let me know. Okay, the next set of problems, sort of review. We are going to apply the exponent on the outside to both terms on the inside. So this can be rewritten as 5 squared over 36 squared. Oops, not 36. I answered it as I was writing it. Over 6 squared. And yes, I do want you to simplify these. So 5 squared is 25, and 6 squared is 36, and that would be your final answer. Okay, 18 is a little bit different because that 3 has to be applied to every single term within the parenthesis, the 2 and the x, the 3 and the y. So I can rewrite this as 2 to the power of 3, x to the power of 3, over 3 to the power of 3, y to the power of 3. and then I can simplify it, okay? So 2 to the power of 3 is 8. 3 to the power of 3 is 27. And I need to, oops, I'm glad I caught that. This should be X, not Y. Okay. And then I need to check to see if I can simplify my coefficients. 8 over 27 does not simplify out, so this would be my final answer. And some of you may be asking, well, why don't you subtract your exponents? I cannot subtract my exponents if the term they're attached to is different. So since this is an X and this is a Y, I cannot subtract them. I have to leave them alone. Okay. All right, so now we are going to apply negative exponents to terms within the parenthesis. So we end up here with a 5 to the power of negative 2 over 6 to the power of negative 2. And so whenever you come to a situation like this, you'll want to move your terms around to make those exponents positive, then simplify. So this becomes 6 squared over 25 squared, or 5 squared. And my final answer would be 36 over 25. And I can't simplify that, and don't turn them into mixed numbers. Okay. Now, we come to a problem like this. This is a little bit different. There is a negative in front of the parenthesis. It's the same as saying there's a negative 1. Okay, so when I rewrite this, I'm going to rewrite it as a negative 1 here, and then I'm also going to apply the negative 3 to every term within the parenthesis. So negative 1 times 4 to the power of negative 3, x to the power of 5 times a negative 3, and then 3 to the power of negative 3 and y squared times a negative 3. Now, if you remember from our last lesson, 5-3, anytime you have a power raised to a power, you multiply those powers. So in the classroom, I would have paused to let you think about it or answer it, and I got to get used to not being inside the classroom. Okay, this looks like a big monster. So some of you would have probably already simplified this part in your head, so you would have said, okay, well, 5 times negative 3 is negative 15, and you just would have written that, and that's fine. I am going to rewrite this again. Negative 1 times 4 to the power of negative 3, x to the power of negative 15, all over 3 to the power of negative 3, y to the power of negative 6. Oh, that's a big parenthesis. And I'm going to come down and do my next step here. Okay, so with this, every single one of our exponents is negative, so we're going to move all of our terms on the bottom up and all of our terms on the top down. So I'm going to rewrite this again. So now we have 3 to the power of 3, y to the power of 6 over 4 to the power of 3, x to the power of 15. So we're really applying almost every lesson we've done so far into this one problem. Okay, I'm going to rewrite it again. Negative 1 times 27 y to the power of 6 over 64 x to the power of 15. And we're almost done. We have this negative still to deal with, okay? So our final answer is a positive 27 over 64. So we're going to multiply that by a negative 1, which means that the whole answer will end up being a negative. Okay, so let me make sure. Yeah. So I will have my final answer as a negative. I'm going to have to write really small now. 27y to the power of 6 over 64x to the power of 15. And this right here would be my final answer. Okay, that's a lot of work. Okay, 1 second. Okay, my dog was in here with me and he wanted out. So, okay, let's move on to example 21. Okay, I'm going to apply the power of 3 to both terms on the top and both terms on the bottom. So this becomes 4 to the power of 3, r to the power of 5/3 times 3, and I'm going to put a 3 over 1 because in just a minute I'm going to cross simplify those fractions. Okay, and then that's going to be over 2 to the power of 3, r to the power of 3. All right, now I can go ahead and solve for 4/3 and 2/3. 4/3 is 64. 2/3 is 8. And then here, r to the power of 5/3 times 3/3. I'm going to simplify that so that it'll be a little bit easier. And now I end up with 5 over 1, which is just r to the power of 5. And then I can't do anything else with that one, so it's just r to the power of 3. Okay, we're not finished. We're going to continue to simplify this. We have 64 divided by 8, which is going to give us 8. And then we have r to the 5th minus r to the 3rd, which is going to give us r squared. So and then that would be your final answer. Okay. Right, moving right along, we are going to rewrite this as 6 to the power of 3 and 3 to the power of 3. Okay, that's 2 times 3. And we end up with 6 times 6 is 36. 36 times 6. No, I could not do this in my head. I've already done this problem. It's 216. And then 4/3 times 3 over 1 is going to give you 4. It would give you 12 over 3, which simplifies to 4, or I could have cross simplified these again like I did the other problem, and you end up with 4 over 1 or just 4. And then I have 3/3 is 27. P 2 times 3 is 6. Okay. Now I need to simplify my coefficients and simplify my variables since they are the same. So 216 over 27. Okay, so I know that I can divide these both by 27. Okay. And if you use your calculator, you'll see that 216 divided by 27, I believe it's 8. So 216 divided by 27 is 8. And then we have p to the power of 4 minus 6. So we have 8 p to the power of negative 2. And we can't have that negative, so we're going to have to move the variable down. So we end up with 8 over p to the power of 2. All right. Let's go ahead and move on to example 23. We have x to the power of negative 4, y to the power of 5 times negative 4, all over x to the power of 7 times negative 4, y to the power of negative 4. And now I need to simplify some of these exponents out. So I'm going to do that right now. Okay, Now, normally at this point, I would say move all your negative exponents from the bottom up and your positive exponents down. But because they're the same, I can do what we said in step 1 right here, rewrite your problem by moving all terms to the numerator. So I'm going to do that. Okay. So when I do this, I have x to the -4th, and remember when we divide, we're subtracting those exponents. So if I subtract a -28, I'm actually adding 28. And then y to the power of -20 minus a -4 is the same as adding a 4. So I'll simplify those out. I end up with x to the power of 24, y to the power of -16. And we can't have a -16 there. So we will rewrite this as x to the power of 24 over y to the power of 16. Okay, moving on to example 24. Now, because there are so many terms in here, I am going to eliminate that first step, and I'm just going to multiply my powers by my power. Okay, so here I have 4 to the power of -4, and then x to the power of 3 times the power of -4 gives me x to the power of -12. Y to the power of 6 raised to the power of -4 gives me y to the power of -24. Z to the power of -3 times -4 gives me z to the power of 12. And then the bottom, 6 to the power of -4, and then I have x to the power of -4, and z to the power of 5 times -4 is -20. Okay, so in this one, I can go ahead and switch my coefficients because they're both negative, so we need to move them. But then my variables can all be combined together in the numerator. So I'm going to rewrite that down here. 6 to the power of 4 over 4 to the power of 4. 64. And then I have x to the power of -12 plus 4, y to the power of -24. I don't have a y down here, so I'm just going to leave that. And then z to the power of 12 plus 20. Okay, so 6 to the power of 4 is a big number. It's 1296 over 4 to the power of 4 is 256. Then we have x to the power of -8, y to the power of -24, and z to the power of 32. Okay, so we need to simplify our coefficient and we need to move our negative exponents around. So I have already done the simplifying on this. When you simplify this out, you end up getting 81 over 16. And then your z can stay as on the numerator because it's positive, but I'll need to move my x and my y down to the denominator because they're both negative. So x to the power of 8, y to the power of 24. And I've completely encroached on example 26, but I'll just put an arrow up here. There we go. That's not very pretty. Oh, you guys could not see that, could you? The whole time. Well, here's the work. I'll let you see it there. Okay, moving on to example 25. Now with example 25, we're going to go back to lesson 2 where we combined terms that had exponents, okay? And so remember, you can add your exponents if the variables are the same. So in this case, I can multiply my 6 and my 5 together to get 30. I cannot, though, combine my a and my b because they're different variables, so I just write those out. Okay. Then in the denominator, now the thing with the denominator here is this term right here has an exponent on the outside. So this term actually becomes negative a to the fourth, b to the fourth. Okay, so I can get rid of that, and I've rewritten it here. So now I can combine these. Now also remember that this negative will represent a -1. Okay, so I have 3 times a -1 is a -3. A to the -5th times a to the 4th. Remember, we are, when we multiply terms, we add the exponents. So it'd be -5 plus 4, which is a -1. There's no b over here to combine with this b, so we just leave it as b to the 4th. Okay. So now I can simplify my coefficients and simplify my variables. So 30 divided by -3 is a -10. A to the 4th, now that we're dividing, we're going to be subtracting our exponents. So 4 minus a -1 is the same as 4 plus 1. So we have a to the 5th, and then b to the 7 minus 4 is 3. And so this is our final answer right here. Okay, let's look at example 26. This one looks pretty easy, right? We're just combining these. So we have a to the 5th minus the 4th, and b to the 8 minus the 9. So a to the power of 1, b to the power of -1. And we can rewrite this as a over b. A to the power of 1 over b to the power of 1. You don't even have to write those powers. So then this would be, all right, sorry. Okay. All right, we are almost done. I know that these are a lot of notes. Our next set isn't going to be quite this much. The concept here, though, is pretty simple once you get the hang of it. So I wanted to get a lot of practice in before you started on the homework. Okay, how to solve problems involving scientific notation and division. So you want to divide your constants and then divide your powers of 10, meaning you're going to be subtracting the exponents. Then you'll move your decimal if you need to. Remember, when you move your decimal to the left, you are adding 1. When you move it to the right, you are subtracting 1. And then write your answer in scientific notation. Okay, so the first step, divide your constants. So I have to divide 4.2 divided by 1.2. So we have 3. We have 6, add a decimal and a 0, and bring that down. 12 goes into 65 times. Okay, all right, so we end up with 3.5. And then 10 to the power of 8 minus 3 gives you 10 to the power of 5. So I've done steps 1 and 2. I divided my constant and I got 3.5. I divided my powers. And now I'm going to write it in scientific notation. 3.5 times 10 to the power of 5. And since the decimal is behind the very first number, I do not need to move it. This is my final answer. Example 27, step number 1, divide your numbers here, and you end up with, okay, 0.9, and then you have 10 to the power of -5 plus 2. I know we're supposed to subtract, okay, and then we get 10 to the power of -3. Now with scientific notation, do not forget that you can leave your exponents as negative. That's the only situation at this point where you can do that. So I'm going to put these together, 0.9 times 10 to the power of -3. However, the decimal is not behind the first natural or whole number, right? So we have to move it, and we're going to move it one place to the right. If I move it to the right, I have to subtract 1 from my exponent. Okay, So I end up with 9.0 times 10 to the power of negative 4. That's a decimal. Okay. And that's my answer. Okay, here we go. Example 28. A computer-generated typist can type 5.2 times 10 to the power of negative 5 words per second. That's a lot. How many words can the computer type in 4 minutes? Okay, well, we need to turn those minutes into seconds because that's how this is measured right here. So I know that each minute is 60 seconds. So I would take 60 times 4 and get 240 seconds, okay? And then what I would do is I would take and multiply 240 times 5.2 and multiply that by the 10 to the power of negative 5. So 240 times 5.2 is 1,248 times 10 to the power 5. Now in this case, I am going to have to move my decimal over 3 times because there's no decimal there. So we put it at the end, 1, 2, 3. I moved it 3 places to the right. So to the left. So I'm going to add 3 to my exponent and I end up with 1.248 times 10 to the negative 2nd power. And this is my final answer for that one. Okay, so your notes had a lot more practice than what your homework is going to. The homework is 5-4. I don't have a blank copy with me, but it's 5-4 practice division properties of exponents. And the homework for 5-4 will be due for my Tuesday, Thursday class next Thursday, which I believe is, I don't want to get the dates wrong again, but I believe that that would be April 2nd. And for my Wednesday, Friday classes, it will be due April 3rd. So next Thursday and Friday. These will be due a week from today. So if you have any questions at all, please email me. And don't forget about the help classes. I will be sending you links to those shortly. All right, thank you.